Hi, Mr. A here. The first thing I want to remind you is that if you want to fast forward, skip ahead, use the timestamps, rewind, watch it at 2 times speed, watch it at half speed. This is a video, so make sure you use it like one. If you need to watch this the way you need to watch this to get the lesson, then that's the beauty of watching a recording and not seeing an in-class presentation. Okay, so the first thing I should probably cover in this video is Algebra 1 basics, because there's some things that we may or may not have learned or remembered from 8th grade or 7th grade that have to deal with basic definitions and the things that we should be able to do to an equation or an expression. And if I go through them today, maybe that'll make it easier when you try to do things like distribution or multi-step equations. So without further ado, let's talk about some definitions first, just some basic ones. Definitions, still a math teacher. Definitions. The first would probably be solving. So this definition of this word, solving, we could see this in many ways. Sometimes it's written as evaluate, or maybe find the number. But either way, anytime you see a phrase like this, it's talking about if I'm given something like x plus 3 equals 0, something like that, then all it means when I'm solving it, all it means when I'm evaluating it or finding x, is just moving everything. So if 3 is on this side and x is on this side, solving for this number x, because that is the number, would mean moving everything, so in this case 3, to the other side of the equation and being left over with x, having x left by itself. So solving means moving everything to one side of the equal. And one more thing would probably help. Oops. Moving everything to one side of the equal and leaving the variable So when I say variable, I guess this is a definition in a definition. The variable is just the letter. So maybe it's x, maybe it's a, maybe it's b, maybe it's y, maybe it's q. But it's the letter that we don't know the number of. In this case, it's x. So leaving the variable by itself on the other side. So altogether, moving everything to one side of the equal sign, but leaving the variable, or the letter, in this case x, all by itself. If we do that, we have solved the equation, or we have found the number. So in this case, this would look like moving this x plus 3, so let's move. That's maybe not a mathematical way of saying, let's cancel this 3 on this side. How do I make 3 on this side of the equal sign, this side, disappear? And we do the inverse, or the opposite operation. So the opposite of addition is subtraction. So we subtract 3. And if I ever do one thing, any operation on one side of the equation, I must do it on the other side of the equation. So I'm left with x 3 minus 3, that's plus 0, equals 0 minus 3 is negative 3. X plus 0 is the same thing as saying x, because 0 is nothing. And now x equals minus 3. So take a look. We have moved this positive 3 to the other side of the equal sign. So imagine there's an imaginary line, and the only thing left on this side, the only thing left, is the variable x. And if everything else is on the other side, then x equals negative 3. So that is solving. The next thing we should talk about is like terms. So like terms, you've probably heard that a lot, especially combining them. Combining like terms. And this is really important if we're ever adding or subtracting. So one really easy example, if I'm given 4 plus 3, easy enough, I can add these. 4 plus 3 equals 7. What we don't talk about before now is that the reason we can combine these, the reason we can add them, is because both of these numbers, 4 and 3, are like terms. So what does it take to be a like term? All you need is a couple of things. You need to have the same exponent and the same variable. So you might ask, well, Mr. A, 4 and 3, they don't have exponents. They don't have variables. The fact that they both don't means that they do have the same variable. So if we don't have a variable, that variable is just something to the 0, or it doesn't exist. The exponent is the same exponent that makes it not exist. So, without getting too complicated, maybe I have x squared, and let's add 4x squared to it. Okay, so what did I say? It needs to have the same exponent and it needs to have the same variable. So if we take a look, my exponent is squared, or raised to the power of 2, and my variable in blue is the x. It doesn't matter what 4 is, and we hopefully know that if I have x squared, then there's an invisible 1 in front of it always. That is the coefficient in front of x squared. And in this case, 1 and 4, it doesn't matter if they're different. All that matters is I have the same variable and I have the same exponent. These two numbers are like terms. Which means it's not that I have to add them, I could even subtract them. Easy enough. And we know x squared plus 4x squared, that would give us 5x squared. X squared minus 4x squared, that would give us minus 3x squared. Okay, so we can add these. So why does this matter so much? Is that if we're adding or subtracting, and I have things that are not like terms, let's say I have 3 plus 2x squared. Then if I say combine them, or add them, or subtract them, I can't, because they do not have the same variable, and they do not have the same exponent. And because of this, I can't add them. I'm done. I'm stuck. I can't go any further. So that's an important fact. So like terms, solving like terms. What's another thing we should talk about? The last thing I want to talk about is this term coefficient, or this word coefficient. Okay, we'll see it quite often, and I probably used it in these definitions above, so I'm sorry if you don't know what it is. The coefficient, so let's say I have 2x squared. The coefficient is 2. It's just the number, or the constant. In front of the variable, or being multiplied by the variable. What that means is, so I say 2x squared, then the coefficient is 2. That is because 2 is the number. And it's being multiplied by x squared, because anytime we write 2x squared, this is the same thing as saying 2 times x squared. We just don't take the trouble to write the multiplication sign anymore. It's 2x squared, 2 of the x squareds, so 2 times x squared. So let's say I'm looking for the coefficient of 8x. The coefficient is 8. Easy enough. And like I said before, what if I'm looking at the coefficient of x? What is the coefficient of x? Just x by itself. Because remember I said, anytime I have 2x squared, it's really 2 times x squared. So if all I have is x, then what is this missing number here? What is something in front of x that is being multiplied that'll just give us x? The answer is the coefficient is 1. 1 times x. And that makes sense. We don't write the 1 because that'd be a waste of space. It's 1 times x. And this is just x. So anytime you see a variable or a letter that's all by itself, there is an invisible coefficient, a 1, being multiplied in front of it. So if I have y, the coefficient is 1. Or if I have a, then a's coefficient is 1. That's because it's actually 1 times a. And that's why I can add a plus a, because they do have the same variable. And that's 1, which is 1 times a and 1 times a. So they have the same variable, they have the same coefficient, which in this case is 1, which also doesn't show up. Then they're like terms. A plus a equals 2a. And I think that's all the definitions you really need to get the basics of algebra. The coefficient, like terms, and what does it mean to solve an equation. Okay, that's all. Good luck.